Hey everyone, welcome back to Set for You. In today's video, I'll be working through algebraic expressions from the AS Pure Maths course. This chapter covers indices, expanding brackets, factorising and surds. A copy of this worksheet is also available on my Discord channel, so grab a pen, some paper and a calculator and let's get started. In the first question, we are told to expand and fully simplify this expression. So the first thing I'm going to do is expand and simplify the last two brackets. So I have x squared minus 3x plus 8x minus 24, and we can write this as x minus 4 multiplied by x squared plus 5x minus 24. And so when we expand this, we have x cubed plus 5x squared minus 24x minus 4x squared minus 20x plus 96. And after simplifying this, we get x cubed plus x squared minus 44x plus 96. In the next question, we are told to find the values of m such that 8 to the power of 4m multiplied by 2 to the power of m squared minus 3m multiplied by 4 to the power of 2 minus 3m divided by 16 cubed equals 1. So the first thing we need to do is write each term as a base power of 2. 8 is 2 cubed, so we have 2 cubed to the power of 4m multiplied by 2 to the power of m squared minus 3m multiplied by 4, which is the same as 2 squared, all raised to the power of 2 minus 3m, divided by 16 cubed, which is the same as 2 to the power of 4, all raised to the power of 3, and all of that equals 2 to the power of 0. So we have 2 to the power of 12m multiplied by 2 to the power of m squared minus 3m multiplied by 2 to the power of 4 minus 6m divided by 2 to the power of 12, and that equals 2 to the power of 0. And given as all the indices in our fraction have the same base, we can add the powers in our numerator and subtract the power in our denominator and set that equal to 0. So 12m plus m squared minus 3m plus 4 minus 6m minus 12 equals 0. Therefore, m squared plus 3m minus 8 equals 0. So if we complete the square, we have m plus 3 over 2 all squared minus 9 over 4 minus 8, and that equals 0. So m plus 3 over 2 all squared equals 41 over 4. And after square rooting both sides, we have m plus 3 over 2, and that equals plus or minus root 41 over 2. So the final answer is m equals minus 3 plus or minus root 41 all over 2. In the next question, we are told to write this fraction in the form bx to the power of c times y to the power of d, where b, c, and d are integers. So using the law of indices, I can write this as 12 squared multiplied by x to the power of 8 or squared times y to the power of 4 or squared divided by 8 times 6, which is 48, and x cubed times x squared is the same as x to the power of 3 plus 2, because whenever you multiply two indices with the same base, you have to add their powers. So in this case, we have x to the power of 5 multiplied by y to the power of 6 plus minus 2, which is 4. And using the fact that x to the power of a raised to the power of b equals x to the power of a times b, we can write the numerator as 144 multiplied by x to the power of 16 multiplied by y to the power of 8 divided by 48 x to the power of 5 y to the power of 4. And so when you simplify this, you have 144 divided by 48, which is 3, and x to the power of 16 divided by x to the power of 5 is simply x to the power of 11. Once again, if we use the law of indices, we can state that x to the power of a divided by x to the power of b is x to the power of a minus b, and so we can write y to the power of 8 minus 4, which is 4. So the final answer is 3x to the power of 11, y to the power of 4. Before we get into the next question, if you like more support outside of these videos, make sure you join my Discord community, because that's where I'll be sharing extra questions and revision tips for GCSE, A-level and engineering math students. I also offer one-to-one and small group tuition along with weekly live sessions where we work through exam-style problems together. Now, let's get right back to the questions. Express x in terms of m, show you're working clearly, and simplify your expression. So the left-hand side of this equation can be written as 12 multiplied by 4 to the power of 3m plus 4 divided by 4 multiplied by 4 to the power of m plus 5, and we'll set that equal to 2 to the power of x. And 12 divided by 4 is 3, multiplied by 4 to the power of 3m plus 4 minus m plus 5, and we're going to set all of that equal to 2 to the power of x. So 3 multiplied by 4 to the power of 2m minus 1 equals 2 to the power of x. And if we write 4 as a base power of 2, that's 2 squared, all raised to the power of 2m minus 1, and that equals 2 to the power of x. So 3 multiplied by 2 to the power of 4m minus 2 equals 2 to the power of x. And in order to simplify this, we need to write 3 as a base power of 2. So I'm going to state that 2 to the power of y equals 3. So when we take log of both sides, we have log of 2 to the power of y, and that equals log 3. So y log 2 equals log 3. Therefore, y equals log 3 divided by log 2. And this can also be written as log base 2 of 3. So we have 2 to the power of log base 2 of 3 multiplied by 2 to the power of 4m minus 2, and that equals 2 to the power of x. And using the law of indices, we know that whenever we multiply two indices with the same base, we need to add their powers. So we can write this as 2 to the power of log base 2 of 3 plus 4m minus 2, and that equals 2 to the power of x. So the final answer is x equals 4m minus 2 plus log base 2 of 3. Express root 392 plus root 98 divided by root 2 in the form root n, where n is an integer. So the first thing we need to do is rationalize the denominator by multiplying the numerator and the denominator by root 2. So in our numerator, we have root 2 multiplied by root 392 plus root 98 divided by root 2 multiplied by root 2. And root 392 can be written as 14 root 2 plus root 98, which is the same as 7 root 2, and we'll divide that by 2. And the numerator can be written as root 2 multiplied by 21 root 2 divided by 2. And this simplifies to 21. And given as we need to express our answer in the form root n, we can write this as a square root of 21 squared, which is simply the square root of 441. In this question, we have been given the equation root 8 divided by 4 cubed divided by 32 to the power of 3 over 2 equals 2 to the power of m. Determine the value of m. So the first thing we need to do in this question is write each term as a base power of 2. So I'm going to write root 8 as root 4 times root 2, which is the same as 2 root 2, multiplied by 32 to the power of 3 over 2 all over 4 cubed. And that equals 2 to the power of m. 2 root 2 is the same as 2 multiplied by 2 to the power of a half, multiplied by root 32 all cubed, divided by 4 cubed, and 4 is the same as 2 squared, so I write it as 2 squared cubed, and that equals 2 to the power of m. And given us 32 is the same as 2 to the power of 5, if we raise 32 to the power of a half, which is the same as square rooting it, we need to raise 2 to the power of 5 to the power of a half. So root 32 is the same as 2 to the power of 5 over 2. So the left hand side of the equation can be written as 2 to the power of 3 over 2 multiplied by 2 to the power of 5 over 2 all cubed divided by 2 to the power of 6, and that equals 2 to the power of m. And using the law of indices, we can state that m equals 3 to the power of 2 plus 5 over 2 multiplied by 3 minus 6. So the value of m is 3. Show that 12 divided by root 2 minus 1 minus root 2 to the power of 5 equals 2 root 32 plus 12. So by starting with the left hand side of the equation, we have 12 multiplied by root 2 plus 1 divided by root 2 minus 1 multiplied by root 2 plus 1 minus 2 to the power of a half, all raised to the power of 5. And this gives us 12 root 2 plus 12 divided by 2 plus root 2 minus root 2 minus 1 minus 2 to the power of 5 over 2. And given as root 2 and minus root 2 cancel, we're dividing this fraction by 1. So we can write this as 12 root 2 plus 12 minus 2 to the power of 5 over 2. And whenever you raise a number to the power of a fraction, you can take the root of the denominator and raise that to the power of your numerator, or you can raise a number to the power of the numerator and then take the root of the denominator. So in this case, we have 12 root 2 plus 12 minus root 2 to the power 5. And 2 to the power 5 is 32. So we have 12 root 2 plus 12 minus root 32. And so we can write this as 12 root 2 plus 12 minus 4 root 2. So we have 8 root 2 plus 12. 8 is the same as root 64. So we can write this as root 64 multiplied by root 2. And what I'm going to do is write that as root 128 plus 12. And if we divide 128 by 32, we have root 4 multiplied by root 32 plus 12. And so the final answer is 2 root 32 plus 12. Therefore, the left-hand side equals the right-hand side. Root 5 times root 72 plus root 32 can be written in the form a root 10, where a is an integer. Find the value of a. So we have root 5 multiplied by root 72, which is the same as root 36, multiplied by root 2, plus root 32, which is the same as root 16, multiplied by root 2, and this equals root 5 multiplied by 6 root 2 plus 4 root 2, and we can write this as root 5 multiplied by 10 root 2, and that gives us 10 root 10. So the value of a is 10. Work out the value of 125 to the power of 2 over 3 minus 1 over 2 to the power of minus 2. So we can write the first term as the cube root of 125, or squared, minus 2 over 1 to the power of 2. And the reason I've taken the reciprocal of 1 over 2 is to get rid of the negative power. So we have 5 squared minus 2 squared, which we can write as 25 minus 4. So the final answer is 21. Determine the value of 64 divided by 216 to the power of 2 over 3. So whenever you raise a number to the power of a fraction, so in this case we have x to the power of p over r, we need to take the root of the denominator and raise that to the power of the numerator. So in this case, we're taking the cube root of 64 over 216, and then we're going to square that value. The cube root of 64 is 4, and the cube root of 216 is 6. And when we square this fraction, we get 16 over 36. Determine the value of a plus b plus c. 1 over 6 can be written as 6 to the power of minus 1. Therefore, a equals negative 1. 36 root 6 is the same as 6 squared multiplied by 6 to the power of a half. So we can write this as 6 to the power of 5 over 2. Therefore, b equals 5 over 2. And 1 over root 6 can be written as 1 over 6 to the power of a half. And we can write this as 6 to the power of minus a half. So c equals minus a half. So a plus b plus c equals minus 1 plus 5 over 2 minus a half. When you put that into your calculator, you get 1 as the final answer. Work out the value of b and the value of p. Using the law of indices, we can write this as b to the power of 1 over p multiplied by x to the power of 6 over p, and this equals 9x to the power of 4. And for this to be true, we need to set the non-x terms equal to each other and the x terms equal to each other. So x to the power of 6 over p equals x to the power of 4. And given as these indices have the same base, their powers must be the same. So we can state that 6 over p equals 4. Therefore, p equals 6 over 4, which simplifies to 3 over 2. And after we set b to the power of 1 over p equal to 9, so b to the power of 2 over 3 equals 9, and we can write the left-hand side as a cube root of b, or squared, and that equals 9. And after square rooting both sides, we can state that the cube root of b equals 3. Therefore, b equals 3 cubed, which is 27. Fully factorize and simplify this expression. So the first thing we need to identify is if there are any common factors in each term. And when we take a closer look, we can see that 2x plus y is common in each term, and the highest power that 2x plus y has been raised to is 1, so we can take out a factor of 2x plus y from each term. So in my brackets, I have 2x plus y squared minus 7x multiplied by 2x plus y plus 10x squared. We can fully write out a second bracket as 2x plus y multiplied by itself minus 14x squared minus 7xy plus 10x squared. And after expanding our brackets, we have 4x squared plus 4xy plus y squared minus 14x squared minus 7xy plus 10x squared. And this gives us 2x plus y multiplied by minus 3xy plus y squared. And after factorizing y from the second bracket, we can write this as y multiplied by 2x plus y multiplied by y minus 3x. Write this fraction in the form b root 5 plus c divided by d, where b, c, and d are integers. So the first thing we need to do is rationalize the denominator for both terms. So I can write this as 4 root 5 multiplied by 3 plus root 5 divided by 3 minus root 5 multiplied by 3 plus root 5 minus 2 root 5 all over root 5 times root 5. And this gives us 12 root 5 plus 4 multiplied by 5 divided by 9 minus 5 minus 2 root 5 all over 5. And we can write this as 12 root 5 plus 20 divided by 4 minus 2 root 5 all over 5. And in order to subtract these fractions, they need to be written over the same denominator. And the lowest common multiple of 4 and 5 is 20. So I need to multiply this denominator by 5 and this numerator by 5 and this denominator by 4 and this numerator by 4. And that gives me 60 root 5 plus 100 minus 8 root 5. So the final answer is 52 root 5 plus 100 all over 20. Factorize fully this expression. The first thing we need to do is factorize the highest common factor from 24 and 150, and that is 6. So we have 6 multiplied by 4m to the power of 4 minus 25. And hopefully you'll recognize this as a difference of two squares. And remember, if an expression is in the form of a squared minus b squared, we can write this as a plus b multiplied by a minus b. So in this case, our final answer is simply 6 multiplied by 2m squared plus 5 multiplied by 2m squared minus 5. Show that q plus 8 multiplied by 2q minus 7 multiplied by 2q plus 5 can be written in this form, where b, c, d, and e are integers to be found. So the first thing we need to do is expand the last two brackets. So we get 4q squared plus 10q minus 14q minus 35. And after simplifying our second bracket, we have 4q squared minus 4q minus 35. And once we expand this, we have 4q cubed minus 4q squared minus 35q plus 32q squared minus 32q minus 280. And that simplifies to 4q cubed plus 28q squared minus 67q minus 280. Therefore, b equals 4, c equals 28, d equals minus 67, and e equals minus 280. Factorize b squared minus c squared. So this is simply the difference of two squares, so we can write our answer as b plus c multiplied by b minus c. Hence or otherwise, simplify this expression. So hopefully you'll notice that this is also the same as the difference of two squares. So I'm going to label the first term as b and the second term as c. And using the answer from the previous part of this question, we can write this as d squared plus 4 plus d squared minus 2 multiplied by d squared plus 4 minus bracket d squared minus 2. And that gives us 2d squared plus 2 multiplied by 6. So we get 12d squared plus 12. And after factorizing that, we get 12 multiplied by d squared plus 1. Factorize fully this expression. So using the AC method, we can multiply 8 by minus 3, and that gives us minus 24. And two factors of minus 24 that add to give minus 2 are minus 6 and 4. So we can write this as 8y squared plus 4y minus 6y minus 3. So after factorizing 4y from the first two terms, I get 4y multiplied by 2y plus 1. And after factorizing minus 3 from the last two terms, I have minus 3 multiplied by 2y plus 1. So the final answer is 2y plus 1 multiplied by 4y minus 3. In the final question for today's video, we are told to express 16 to the power of 4x plus 1 in the form 4 to the power of y, given y in the form cx plus d, where c and d are constants. So very easily, we can write 16 as 4 squared and we'll raise that to the power of 4x plus 1. And using the law of indices, we can multiply the powers, so we can write this as 4 to the power of 8x plus 2. Therefore, y equals 8x plus 2.